Good morning to everyone. For me, it's really morning because I woke up at 4 a.m., jumped into the car, and drove here from Poland. And funny thing is that the total road took me like 3.5 hours, whereas on the motorways, 2.5 hours, 1 hour in traffic jam in Berlin. So, good morning again. So I will try to speak about the supporting role of the IT for the lithium-ion batteries, transportation, and SOH monitoring. Some information about me, which is not so important. I used to work for the automotive companies and have like 15 years of background in mechanical and supply chain. And since more than 10 years, I joined the electric business. So all of sudden today, we are talking about this electric revolution of the vehicles. And I am a part of this since more than 10 years. Today, I will try to introduce our company. I will talk about the lithium-ion batteries, which is a topic very popular nowadays. I will speak about the safety regulation for ion batteries transportation, supporting role for the lithium-ion batteries transportation, ERP and cloud-based system, data analysis, and that's it. Yes, as I mentioned, I spent a lot of time today in the morning in traffic jam in Berlin, but as you can see, 5.5 billion hours every year we are spending in traffic jams. All the energy and all the dust which is created by the cars are causing about 3.7 million of death a year. And 5.5 billion, the estimation, 5.5 billion of the tons of the CO2 are generated by the traffic. And it is predicted that in 2030s, the 6.3 billion of the global population will be living in mega cities. And in 20 years from now, as Stephen Hawking said, we will double our population worldwide. So what we are doing, we are an electric scooters producer, and we are a fast-growing pioneer in this market. So right now, as you can observe, for those who are observing this electric vehicles revolution, we are talking about the electric Teslas, electric BMWs, basically all biggest car makers, they have nowadays the electric cars. We are there as well, but as a two-wheeler producers, and frankly speaking, since many years, because we have started our serial productions at the time 2008, 2009, when the big companies, they were just designing, developing these electric vehicles. It is about GOVECS group. We are a relatively smaller company. I used to work for the biggest automotive company in the world, but it's more fun here. We have 4 locations: USA, Europe, in Germany, in Munich, and Berlin here, and as well our operational site, supply chain, is in Wrocław, in Poland, where we have our R&D, order purchasing, and manufacturing. And the USA, today we are making this distribution of these electric vehicles, and our sales and marketing team is located in Munich. As previously mentioned, Munich is our head office. This is our operations, and I will play you a small video about our company, what we are doing, and what products we are providing to the market. There is a lot of manual operations, like in every car assembly. Of course, there are as well robots, but usually our quality and the job is based on skills of our employees. For these who are from the, especially East Germans, we are putting this year a famous Schwalbe back to the road, and this Schwalbe is fully electric, and we do cooperate with a known brand like a Bosch for all the drive system development of these vehicles. So it is like an icon is back. You can as well go and make the configuration on the online for this vehicle. As I told you previously, a lot of manual operations, like 1,500 moves to create one electric scooter. And this is already on the road, launched this year. This movie explains you what we are doing and what we are delivering to the market. We are in different business of the market, like we are in the B2B business, where we are making the renting, sharing, and delivery business. We are on the, as well in the OEM business and in business to customer. And on next slide, you will see that sharing is a growing business, not only for our company, but as well for the automotive business, where you are basically sharing the cars on the streets. This is how we start. First, we registered in 1999. It was our CEO. Then we started, really the company foundation was 2009. Through last 7 years, we are going through different paths and of our company development, producing and designing new products, getting awards like the best vehicles of electric in 2012, 2013. So as you can see, already 5-6 years ago, we were on the market where right now the big car makers are here. Today, this year, we have launched the Schwalbe, which is coming back to the market, and as well a new vehicle, which is electric. This is again about our products and the brands. And where we can use our products. We can use our products in delivery and transportation, so like a special developed transport scooter for a delivery, like pizza posts. We are in the sharing business, where you can see and meet our scooters on the streets of the different cities, using the application to rent it. And since this year, we are delivering. First our years were focusing on the business to business, and from this year we are focusing and turning into the business to the customer. So our scooter, like a GOVECS T series, mostly dedicated for transport and deliveries of the goods, maximum load up to 180 kilograms on one fully charged batteries, 100 kilometers of a distance, and lifetime of the batteries estimated for the 50,000 kilometers. Okay, no smoke, no CO2 emissions, and low maintenance cost. Then we have the Go Rent business, where we are giving in a lease our vehicles to the operators of the different businesses, like a delivery, pizzas, food delivery. Our standard GOVECS series model, which is for consumers like us. And as previously mentioned, since this year, we are going, we have already introduced this business to the customer vehicle, which is a Schwalbe. The sharing. Sharing is a key for urban mobility. As previously mentioned, our population in the big cities is growing. So more and more we will be using and not having by our own the vehicles, but we will just sharing the vehicles with another citizens of the city. With the connectivity and the applications, our vehicles are shared, and you can find them and get them from on the streets of the Barcelona. And right now, some information about the lithium-ion batteries. So why the industry goes into the lithium-ion batteries? Mostly because it is about the energy density. As you can see, like lead-acid batteries, nickel-cad batteries, nickel metal hydride batteries, and lithium-ion, the energy density per kilogram is much greater. So all the vehicles, all the household and medical equipment goes into the lithium-ion. And the volumetric density is going as well. All about this is about specific type of the cells and the manufacturer. Different types of the cells, like cylindrical cells, coin cells, pouch, and the prismatic. It is about the chemistry, what type of the chemistry is in a particular battery, and the names like LCO is from the lithium cobalt oxide. This is a popular choice for the mobiles, and the active material is like cobalt oxide. And the batteries consist as well the separators plus cathode and anode, which is usually from the carbonate or graphite. So we have another type of the battery, which is a lithium manganese oxide. We have as well lithium nickel manganese for the power tools and e-bikes. We have lithium nickel cobalt aluminum oxide for the medical devices and electronic powertrains like a Tesla, and lithium titanate, which is for the UPS electronic powertrain. So when we are talking about the battery pack, it is like 2 or more cells connected together. And these are connected in a series and in a parallel. So all these cells, when are stuck together, we are connecting them in a series and in parallel. Connecting the cells into the battery pack in series and parallel, battery's voltage and its capacity goes up. One single cell is, for example, like 3.6, 3.7 volts. So connecting them, we are getting like a 36 volt, 48 volt, 72 volts. And capacity of the battery pack depends on the particular type of the cell and the cell specification. As on this slide you can see, this is our cell, and this is our battery pack. This is a Tesla battery pack. Increasing battery pack size, number of cells, we are increasing the energy and energy density stored in this pack. And the cells are grouped in modules, and by increasing battery size, we are increasing the energy, and as well a complexity of energy management. So battery management system and this electronic board is responsible for the monitor the state of the health of the battery, and it's responsible for the quality of the battery pack. One of the key role of the BMS, this electronic board, is balancing battery pack. The most important in either we are talking about the electric scooters or the electric cars, the most important is that all these small cells are equally balanced. As you can see right now, there is a discrepancy and difference between the charge between these batteries and these batteries, which can cause potential problems on the market with a vehicle. And all this balancing, it is usually done on the level of the sections. I will go to the previous slide. As you can see, we have the sections of the battery, rather on the sections than on the single battery side. As you can see as well in the big cars, we have the sections of the battery, and all the balancing is done on the level of the sections. So the conditions of the battery pack, its quality and lifetime depends on how well and how good the cells balanced are. Properly designed BMS make this happen, and BMS monitors the state of the health of the battery. Unbalanced cells, unfortunately, creates a difference between cells and sections. Unbalanced cells decrease the lifetime of the battery pack and battery health. In extreme cases, the unbalanced battery cells can create fire, and it happens to the very big brands as well, and probably you heard about some cases, like a planes get down, or the cars in fire, or laptops, or mobile even on fire. The key parameter to control the battery state of health is to monitor the delta voltage between the one cell or the section and another section. So this is the information which is giving us the impression how the good battery is. And in any cases, it gives us an information if we should take an action and potentially, or in worst case, withdraw the battery from the market. Something about the transportations. As dangerous goods are, this is the DG abbreviation, or all the goods which can, under the specific condition, create the harm to the human health and life. Any company which activities include dangerous goods transportation, packing, filling, unpacking, handling, should appoint one or more trained safety advisor for supporting and preventing the risk of the harm. What are the regulations for the lithium-ion batteries transportation? So United Nations recommendation of the test criteria for lithium-ion batteries transportation, and each cells and battery must meet a requirement of the UN Manual of Tests and Criteria, Part 3, subsection 38.8. And all batteries transportation should comply with UN transport tests for air, road, rail, material transport. And these tests are long-lasting tests, where during these tests are short circuit measured, latitude differences, temperature differences, and during this test, usually it takes like 16 to 20 weeks, and during this test, all these potential causes are tried to be examined and influence on the battery pack as well. So this UN test 38.3 for the battery packs, as mentioned previously, is external short circuit, abnormal charge, forced discharge, crash, impact shock, vibration, temperature, cycling, low pressure, altitude. So every manufacturer who is in charge of delivering, or who delivers the battery pack to the market, either by standard standalone battery packs or in the vehicle, is responsible to pass all these tests to just secure the safety of this total system. Something about the labels, how the system should be labeled, and how the batteries before the shipment should be labeled. And those are in the dangerous goods transportation classified in the class 9 of the transport sector under miscellaneous sector. And since 2017, there is a label change for this class 9 with a description and picture of battery cells. The important thing is that the batteries cannot be transported with a stage of charge greater than 30% of the battery rated capacity. So, and the last, I think, which is, I'm getting to the point, how we are utilizing the ERP system and the IT system for the monitor and support our products on the market. So there is a EDI connection. The ERP systems are the standard. You know, a lot of companies, most of the companies are using the ERPs. So there is a standard information flow between us and our battery supplier. And in this information flow, we are providing the request to the supplier what we want, when, and which quantity. And supplier of the battery is in charge to provide us the advanced ship notice with a battery serial number and battery state of the health through the EDI connection. So before the battery is shipped to us, we all know in our companies what are the EDA message data, what types of the batteries are coming and in which state of the health the batteries are coming to us. So even before we get it, we know what to expect. And we are monitoring with this data analysis, we are monitoring what suppliers is sending to us. For example, in this battery pack, you can see there is so many different entry criteria, and we are observing and we are focusing on this delta voltage, which I previously mentioned, which is in this case 9 millivolt, and classify the battery as okay. So through the EDI message, we know before what to expect, but it is a standard ERP EDI system connectivity. Next step is that on the entry to our company, we are just making the receipt of the battery, each single battery into our system again. So it is like a double check what we were supposed to get and there is a comparison between this what was sent and classified by the supplier in this what we are getting on the entry. So at once we can observe on the entry of the battery to our company if during the transportation there was no battery delta difference arise. Next step, using our ERP system on each step of our production, this delta voltage, which is important for us, we are monitoring. So it is on the incoming inspection, it is during the manufacturing process, and it is as well during the final inspection and shipping of the vehicles. We are storing the data in our ERP system. And all starts in our company from the vehicle identification number. So when the manufacturing process starts, we usually start this process from the sales order, and based on the sales order, we are generating in our company the VIN, so vehicle identification number, and this is like a passport of our vehicle. And with this vehicle, we are merging all the critical components, and one of these critical components for us is a battery, which previously we got the information through the EDI from our supplier, what is the data and how good quality of the battery is. So you can see here our assembly line. There is a battery standing, and in this battery consists all information about the serial number, which we already know that this battery is classified as okay. And we are merging this battery with a chassis and with this VIN vehicle identification number. So again, next step of in our production process is the scanning again the battery. So it is like a third check, scanning the battery, merging it into our ERP system, and controlling what was first shipped through the supplier, then what happened on the incoming inspection, and then what is the stage of the battery in our production process. All the information which are gathered so far are stored in the ERP, and in the last stage we are making the final test of the total vehicle. So all this data are analyzed before the scooter is shipped, and when we can observe that there is, for example, delta for us in this case is greater than 50 millivolt, we classified this vehicle or battery as a not okay battery for usage, and we are sending it back to our supplier or scrap it. So scooters are shipped, and what next? And here we are going into the usage of the IT in the supply chain, because when the scooters are shipped, we have the system, cloud-based system, which is connected with our ERP system, and we are using the connectivity to monitor the battery through the CAN communication. So each of our battery type has and the scooter is a battery has a CAN communication system on board, connected with connectivity box inside the scooter. And this connectivity box usually has the SIM card, GSM SIM card, plus each scooter has a GPS antenna. Through the messages, we are constantly monitoring the state of the health of the battery, sending the information to the cloud, and this parameter is set up by us. It can be either every 15 minutes or depends on the usage, every 10 or 15 kilometers. So this setups is up to us, and we are getting this data and storing them into the cloud. Then, from the cloud, we are getting back the data to our system, and we can observe in real time what happens with the scooter on the market. So this is how the IT is supporting us, and this is done through the back-end system control. In case we can see some suspicious VIN, we can, on the app and in our monitoring system, find out where the suspected vehicle is on the market. Then our team is analyzing the data, analyzing not only this delta voltage, which is the most critical for us, but as well other parameters. And based on this data, we can take the preventive action and for example, exchange the battery or take the scooter back from the market for the service. That's it from my side. Thank you.
Got time for one question. Yep, down at the front.
Thank you for the presentation. I was curious about your reverse supply chain, whether you do anything recycling with the batteries or refurbishment once they reach the end of life.
Yes. We have the dedicated companies, signed contracts with the companies which are operating in the different countries. These are connected, and batteries are collected either by the dedicated companies, which are when the warranty is over, or during the warranty, if something is with the battery goes back to the distributor, and from the distributor to our center, and we dispose the batteries with the recycling companies. And it is in case of the business to business. In case of the business to the customer, when we have this, for example, Schwalbe, which I showed you, we have signed the contract with a party, and this party service company, for example, from the German market, when the battery is dead, brings back the battery to us.
Okay, thank you very much.
Thank you.
President. Thank you.